Hello and welcome, everyone. We're about a minute early, so we're going to give everyone a minute to log in and get into the auditorium before we begin, but just wanted to let you all know that we are live. All right, looks like we're now at the top of the hour at 11 a.m., so we'll go ahead and get started. Hello and welcome, everyone, and thank you for joining us for today's webinar, Building a Defense Against Online Video Infrastructure and Web App Cyberattacks. My name is John Yakino, and I work with Limelight Network. Before we jump into the presentation today, I just wanted to point out some of the features on the webinar platform we're using right here. We plan to have plenty of time at the end of the presentation for a Q&A, so if you have any questions, please type them below in the Ask a Question box, which appears right at the bottom of your page under the video player you're seeing here. I also wanted to point out that over on the right, we have a Resources tab. There you will find several resources related to today's topic that will further demonstrate the importance of protecting your online content. Lastly, I wanted to introduce our speakers for today, Charlie Kraus and Jaime Ortega. Charlie is a Senior Manager of Product Marketing over at Limelight, and Jaime is a GTM Program Manager over at Radware. Both of our hosts have years of experience in their respective industries, so we're sure to learn a lot during today's presentation. So, with all that being said, guys, go ahead and take it away.
All right. Good morning, everybody. This is Charlie Kraus. So, long title, Building a Defense Against Online Video Infrastructure and Web App Cyberattacks. So, real quick on the agenda, I'm just going to really be teeing this up with a little bit about video workflows and some of the vulnerabilities before I turn it over to Jaime. So, we got a good agenda. You can see it's very media focused. It's all about risks to online video for all different types of cyber attacks and how you can protect yourself from them. So it's very topical, especially now that the amount of online video that people are watching has really increased a lot since March. Depending on where you look, it's most of the CDNs are seeing anywhere from 10, 20 to 50% increase in their online video traffic on a constant basis around the world, and certainly due to more people at home due to the pandemic. So let me just quick tee this up and we'll get going. So typical online video workflow for a CDN where you ingest live and on demand. Often you do some transcoding or transmuxing. There's a lot of issues with online video because maybe content owners license some of the content and they have to protect it from theft and so forth. So a lot of different services have to be offered. You want to encrypt it, so we use TLS encryption, typically end-to-end. You have DRM to protect it and define what a user or a viewer can do with the video, whether he's only allowed to watch it, can he download it, can he copy it, can he share it, and so forth. And then access control, especially for sport, you may have regional restrictions, so you need to have some kind of access control depending on people's location, so that's a typical service. And then just you want to keep out, you might maybe want to use access lists to just limit the audience to certain people. So all that is typically just part of what you get with a CDN, and none of that is the topic for today. So I want to get right into the heart of this. I'm going to turn it over to Jaime and get into video risks. Okay, Jaime, take it away.
All right, thank you, Charlie. Well, let's get right into it. There we go. So I wanted to start my presentation with one important stat from Gartner. It will set the stage for the rest of my talk here today. So by 2021, Gartner says APIs will account for 90% of the attack surface. That's 90%. We can actually corroborate Gartner's numbers with our own. So if there's one thing I can impress on you from this webinar, is that protecting the APIs should be your #1 priority when it comes to security. So if you don't know how your APIs are currently being protected. Find out from your teams. If you have the right tool or you think you have the right tool for the job, just go double check. If your development or QA group do not have a process to implement and constantly test API security, you have to create one. I think you get the picture of what I'm trying to present. Whatever you do, however you do it, the API attack vector has to be addressed and placed on top of your priority list. We'll go into a lot more details on the tools and technologies needed to protect the APIs in a couple of slides, but first I want to cover some of the most or more common media challenges that we often hear from the field. So changing here. There we go. So here's the list of challenges, roughly ordered in what we come across most often. First and foremost, and by a good margin, is the ATOs, the account takeovers. There are many flavors and many ways on ATOs happen, but most common are the identity theft, either by brute force, the data leaks, or phishing tactics. Credential stuffing through automated API injections. It's the end goal is always the same. It's stealing the user password or to sell them in the darknet or just gain access to privileged areas. Obviously, OTTs are the perfect target for this, so all media streaming services are affected. AVODs, TVODs, SVODs, all of them are affected equally. And again, it's not just your local systems that we need to protect and worry about. Username password reuse is still very common out there. So there's a very good chance that if one provider is breached, a different one will be affected as well. That is, credential stuffing at its best. Tied to the ATO is the protection of the media activation servers. Whether your business centers around pay-per-view, PODs, or subscription-based, the protection of the activation servers is obviously of great importance. It's the gateway to your revenue, so it needs to be protected. We also show concerns on invalid traffic on video ads with fake hits, stream farming to artificially increase pay rates, carding protection for those of you that manage that workload. Let's see, next one, media scraping. So media scraping is interesting because in the media space, not many of you seem to care too much about the scraping of images and reviews and blogs and other site information. I would argue that it's still important IP that needs to be protected, but more often than not, we hear that it's more treated like free advertising. So in any case, I've left the best one for last, and that is the OTT and mobile flow control and interception. So the flow control refers to keeping track of the data flow and applying rules to low probabilistic calls. The invocation context refers to the ability of monitoring the sequence of context of a session and acting on it. So how can we manage and protect OTT, mobile, third-party, business, third-party traffic? I mean, what is the silver bullet? Well, you heard it on the first slide. It's all in the APIs. We got to protect those APIs. The symptoms of a bot attack on APIs. I'm going to skip this. You can read through this later because I want to concentrate on the second piece of this slide, the key API vulnerabilities and Limelight solutions to the vulnerabilities. So first we have the authentication flaws and account takeover. The problem here is that many APIs do not check authentication status when the request comes from a genuine user. So attackers obviously know this and exploit such flaws in different ways. They can do session hijacking. They can do account aggregation. Imitate genuine API calls. Attackers can also reverse engineer mobile applications to discover how the APIs are invoked. And if the API keys are embedded into the application, well, then you have a problem there. Cyber criminals can also perform credential stuffing attacks, to take over accounts, like I mentioned before. So there's all kinds of different ways that the accounts are target. Limelight Security Solution blocks the attempts to scan APIs for vulnerabilities and protects them against automated attack. It also analyzes the API requests and detects and blocks malicious attempts to evade source identification. It does device fingerprinting, and it also avoids direct access to the APIs. The second one, the lack of robust encryption. Many APIs lack the robust encryptions between the API client and the server or the API gateway. So attackers, again, they exploit vulnerabilities through man-in-the-middle attacks. They will intercept unencrypted or poorly protected API transactions in an effort to alter the data, or just good old-fashioned steal sensitive information. Also, since media almost exclusively use API for OTTs and mobile devices and in cloud systems, it kind of further complicates the API security because multiple gateways are now involved in facilitating the interoperability among all these diverse applications. It just gets complicated real quick. The encryption of data flow, the encryption of data flowing through all these channels is important, is paramount. So Limelight Security Solution here provides edge to endpoint API security and ensures a secure data exchange. The third line item here is the business logic vulnerability. So APIs are vulnerable to business logic abuse, and ultimately this is exactly why a dedicated bot management solution is required, and why applying detection heuristics are good for both web and OTT applications. They're just the heuristics are either good for one or the other one. If you apply the same ones to both, it generates all kinds of errors. You will get like false positives and false negatives. So Limelight solution is tailored to learn the communication flow and invocation context. We learn to study the traffic. We can challenge the suspected API calls, anything from your typical captcha when appropriate, to feeding fake data, blocking source, invisible challenges, you name it. We even have an application agnostic SDK that embeds into your code and provides a device and API fingerprinting. The object, of course, is to stop potential business logic abuse, and along with that, all the responses to these challenges and all this technology helps Limelight build a closed loop feedback that kind of dynamically improves the bot manager machine learning models and algorithms. And fourth here is the poor endpoint security. So most OTT devices and microservices tools are programmed to communicate with the server or with the API gateways via API channels. And these devices authenticate themselves on API servers using client certificates. So a poor endpoint security would allow a bad actor to gain control over an API from an OTT or an IoT endpoint. And if they succeed, well, they can easily resequence the API order, and there's your breach. Limelight uses intelligence gathered from its global customer base to take preemptive actions against potential attempts to access the OTT endpoints, the mobiles, and the microservices tools. So yeah, that's all great, but how does it all fit in? What technologies exactly does Limelight provide to protect against API transaction manipulations, protocol attacks, evasion techniques, injections, redirects, data leakage, API abuse, all of it. How do we do this? All right, so this is where the multi-layer protection comes in. So the whole security, the multi-layer protection concept is centered around protecting the application. That is the round circle in the bottom left half of the slide. But what is really an application? How is it defined in the Limelight world? In its simplest form, an application is an IP or a domain, and the security policy that attaches to that domain. So let's say you want to protect your payment side or your activation server side, and you want or you need two different security policies in place. You will create just two applications and configure two separate applications in the system for it. So going back to the slide, again, at the core, we have the protected application. It could be on-prem, it could be on the cloud. It doesn't really matter where it is. And around that core, protecting the app, we have the three main components of Limelight's managed SaaS security service. It is called the Security Pop, and it contains three pieces. It contains the Cloud WAF, which has a unique behavioral-based detection and real-time signature creation. It has a fully featured DDoS solution comes along with the WAF, and there you have the bot manager with its intent-based deep behavioral analysis. We'll cover that in all that in a little bit. So around that, and on top of the security POP, we also have the threat intelligence feed, which enables the POP to receive signatures and security feeds from known attack types detected in our global network. It's a global deception network. It's basically just a bunch of honeypot systems that spread all around the world that are purposely built to catch attacks. So we ingest that information from the honeypots and other sources, and then we build the feeds with that. On top of the threat intelligence feed, we have the active attackers feed that actively blocks attackers that are currently active in real time. So that's even before we block them even before it targets the networks. So kind of like the border patrol blocking the known terrorists. Before they come, we know of them. And the final layer, the green one, is the geo blocking, which by itself wouldn't be of much use. But in conjunction with the other layers, it does a job. It does its job and adds to the security posture. So zooming in into the security POP now, we have the WAF. It's a must in order to protect against OWASP top 10 attack list. As a side note here, in a little contrary to popular belief, OWASP does not only apply to regular web traffic. All the same vulnerabilities are attached to the API. So you need to protect against the OWASP top 10. In any case, the WAF has advanced behavioral technology, continuous adaptive policies, layer 7 DDoS, but all other important things, data leakage. But really the one that I wanted to point out is the positive security model it employs. That is what provides the extra protection. So you have the negative security model, which is basically a signature and rule-based protection, but that should be just your starting point. With the negative model, if you have a signature, you can block the signature, but anything outside that, you just basically on your own. So it's not that great and requires a ton of work and upkeep. The positive security model, on the other hand, it learns and defines what actions are legitimate based on prior traffic patterns using machine learning. So in other words, it gets to know the application and automatically builds policies around what it sees. Everything else is flagged or blocked. Kind of like a parent looking over a child. If you know that they never eat broccoli and you see somebody offering them a piece of broccoli, well, you're going to flag it or you're going to intervene. So as I mentioned before, the Limelight WAF comes with a fully featured DDoS standard. I'm not going to talk about DDoS as much, so I'm going to focus on the bot detection here. So WAF and DDoS are, for the most part, known technologies in the enterprise world. They've been around for a while. Bot attacks and bot management, on the other hand, are generally not as well understood. But unfortunately, here's where the sneakiest of the attacks are happening today. So especially in media. So this is an important topic. So to quickly cover the technology on bots, there's basically 4 types of bots, 4 generations. The Gen 1, Gen 2 are your typical scripts, your click fraud and other basic sort of attacks. Actually, a good WAF should be able to handle many of these attacks. Then you have the Gen 3 bots, which have basic human-like interaction capabilities. They are difficult to stop, usually beyond what a WAF can do, but a good bot management solution can handle a good amount of these. And then you have the trickiest ones of all, the Gen 4, the really very difficult to accurately detect and mitigate. They're usually deployed in a distributed way on a large scale and behave just like humans would. So the key technologies that Limelight uses to combat these is the IDBA, the intent-based deep behavioral analysis. It looks and keeps track of prior activities and builds an understanding on where things are going next. So that's a key there. And the other required technologies to mitigate the Gen 4 bots is IP agnostic fingerprinting to combat the distributed nature of the attacks. Without that, you just can block it. I mean, they're just distributed, and if you're using IPs to pick on a bot, is just not going to work. Also, another side note here: many of the today's ATOs, the account takeovers attacks, are considered Gen 4 bots. So it's important to have a good bot detection technology to mitigate these types of account takeovers. So why does it work? So Limelight Security Solution works because there's a synergy between all the products. You might have an API gateway today as an inline security tool to protect your APIs, but that in itself is just not going to be enough. Without a CWAF, you're not protected against the OWASP 10. All the different types of injections, authentication, access control, encryption, configurations, anything that can exist in an API. It just API gateways are just not designed for that, and so they are better than nothing, but it's really a suboptimal security posture. On the other hand, we have the WAF. Not all WAFs understand the differences between API and regular web apps. APIs and webs have both the same RFC baseline, but methods often used in one do not apply to the other one. Okay, kind of like like an HTTP delete or a put. They're rarely used through the web, but they're used through API. And actually, our data shows that 56% of APIs aren't standard web or mobile. So the WAF absolutely needs to understand the APIs intrinsically to avoid false positive. Similar problems for the bots. A snapshot in time is not enough. It needs to be able to track actions through time in an IP agnostic way to really be effective. Without that, it just doesn't work. In any case, again, the synergy of all product and layered services, that is the WAF, the DDoS, the bot manager, the threat intelligence feeds, the attacker's feed, the geo-blocking, all that together is what sets up for the strongest security posture. So I'm finishing up here, but I'm going to finish up with the best practices and how to protect the API infrastructures against hacking abuse. You can kind of read through the list here, but I'm just going to highlight a couple of key terms that we sort of touched on before, and I want to touch on again. First is the authentication. Obviously, know the difference between authentication and authorization. If you're still using basic or token or API key authentication, you probably need to re-examine the solution and cover any gaps that you might find. Most breaches, again, come through some sort of credential hijacking. So this is important to just note this. The encryption, the obvious, encryption everywhere, all the time, no exceptions. It's a must, especially if you're still using those tokens and API keys. Because most times those tokens and keys go along with the request. So if you're not using encryption, that's a big gap there. And the last thing I'm going to highlight here is intent. And if I can be a little blunt here, any product today that cannot deduce intent from prior actions, it's going to be inferior. So just be aware of that. And here, so the last slide before we go into the Q&A. So do breaches really happen? I mean, do they actually happen? I mean, are we worried about something that happens once in 1,000 years? Well, they don't. Just go on Google, do a quick search, and you'll get a bunch of results. What you will also find is that everybody's affected. Big, small, medium, it doesn't really matter. You're going to be a target, and if you're actually looking for it, you'll see that you're a target within minutes of putting anything on the web. So it's important. Just you need to keep your security posture as tight and as strong as you can. And with that, I'm done with my presentation, and I will try to answer however many questions we have, if there's any. And if we don't have time to answer them all, we will just collect them and I'll respond via email.
Awesome. Great work, Jaime. I'll jump back in here. So we do have a couple questions here. I'll start with the first and most popular. What is the latency incurred in deploying these solutions? So maybe if you could speak on that.
Sure. Sure. It's actually, well, it's a good question. I don't have an exact answer because it kind of depends. It's usually in the 1-digit millisecond range, but it depends on where the origin is located as it relates to the security pop. So just keep a little visual in here. So the security pop network is separate from the CDN network. So when the CDN and the security pop networks coexist in the same data centers, then the latency is minimal. When they do not, well, it varies. We have about 24 POPs spread around the world, and security POPs spread around the world, and we also have presence in I think it's 54 Azure regions that they have now, which is it's very useful if your origin happens to be in Azure. But outside that, outside the network, it's also important to note that the traffic that it's usually diverted to the security pop is a dynamic traffic. The static traffic, typically just goes through the CDN unaffected, without any extra hops. So there's really no latency in a penalty there. So really, it's just the dynamic traffic that we were discussing here, and again, it depends on the separation between the CDN pop and the security pop.
Awesome. So actually, we have a pretty good follow-up question to that as well. So can the solution be deployed on-prem?
The solution cannot be deployed on-prem, but you can have your applications on-prem or in the cloud. That does not matter. So the solution is a SaaS model. So it lives outside the origin data center. The mechanics of how the security is injected into the traffic flow is pretty simple. So visually, if you can think of the security pop sitting between the CDN and the origin, that's kind of where it lies. So you have the traffic going in. It sees whether it's a dynamic traffic or static traffic. If it's dynamic, it gets sent to the pop, to the security pop, and then it gets rerouted to the origin. So that's kind of visually how it is, and without getting too deep into the weeds on how the configuration actually happens, it's all done via CNAMEs. So once you create the application, you also create a CNAME that the CDN. The CDN, it's a CDN record, it's a DNS record. The CDN points to that, and then it diverts that traffic to the security pop, and then the security pop kind of diverts once it filters the traffic, it sends it back to the origin. So not deployed on-prem, but the applications can be on-prem.
Sure thing. So appreciate the explanation. I'm sure our audience does as well. I think we have about time for maybe one more question, so I'll go ahead and ask this one here. Can the security be managed from the CDN portal?
No, it can't. There's the CDN portal and the security portal are two different portals. The one thing to note here, though, is that the service, the security service, is a managed service. So you can be the administrator of the tool if you have the resources and the know-how and have the inclination to do that, or you can have the ERT team, the emergency response team, do the administration for you. And I see a little bit of everything. It kind of it's all over the map. Larger companies or medium-sized companies with the established security teams are typically more involved in the process, and they go in and into the security portal and they do things. But larger accounts, for example, they usually have a dedicated team from Limelight that supports their efforts. So at which point the customer barely ever goes into the portal because it's a dedicated team that kind of helps out with that, and they're the ones that go in and out. So unless you have a reason to be there, if you have a dedicated team, there's no portal that you need access to. So yeah.
Excellent. Thank you so much, Jaime. So we're about 1 minute from our 11:30 stop time, so we'll go ahead and cut it there. I just wanted to let everyone know that we will be sending out this the on-demand version of this webinar in a follow-up email to those who attended and registered. As always, we'd love for you to plug us and share it out with your colleagues. And if you have any additional questions, you can obviously still use the Ask a Question feature below, and we'll have a representative get back to you and answer your questions. So with that, we're going to conclude today's webinar, and I appreciate Jaime and Charlie for taking the time to host this for us. And we hope to see you all at another webinar soon. So thank you very much.
Thank you.